Hi students, we welcome you in this session where we are going to perform dissection of Hero Sprint XCT bicycle, and there are a couple of tools which would be necessary to perform this operation. We will tell you before opening this bicycle how well this is working, and we will end this activity by putting the things back, and we will ride this bicycle to make sure that everything is fixed properly in its position. In tools, we have first item reversible screwdriver set, which has got Phillip end and slotted end on other side. Bottom bracket wrench, which is also called BB cup wrench. A ring spanner, which is 14 mm and 15 mm nut size. T spanner for 10 mm nut. Then double ended spanner for 14 mm and 15 mm size nut. Double ended or D spanner for 10 mm and 11 mm nut size. Cone wrench, which will be used to tighten the cones to hold the rolling balls on the either side of the axle. 6 mm Allen key. Then we have a bearing puller. This bearing puller is going to use the replace the bearings on the axle. Universal freewheel wrench for adjusting your rear sprocket on the wheel. Combination plier. 300 grams hammer. This will be used to take out certain parts, but it will be used in combination with the hard wooden piece. 3x8 inch socket set, and out of this we will use 14 mm socket, one extension rod and one ratchet from the set. And this tool set we will use to operate with bearing puller. It can be shown here. So use the tool to tighten and untighten the bearing puller. Pouch of grease, a piece of cloth for cleaning operation if somewhere like we get our hands dirty. And then a pair of gloves is also required. We need a tray to hold certain parts at a proper position in this exercise. And then we have a one tool kit which you can see here, where we keep all these tools so that whenever we do this dissection operation, those are handy and we can issue to the students. The first part in dissection of this bicycle, we will focus on the brake assemblies. See, there is a wire which is hinged between the two springs. So this hinge is locked here on this fork side, and this bearing block is locked on this side, and this V bracket has got a clip on this side which has got a cage for holding the wire in its position, and it can be easily unclamped like this. And then on the other side of the handle side, we have aluminium assembly which has got one lock nut, one extension nut. There is a cut on the extension nut, there is a cut on the lock nut, and there is a passage for wire in the handlebar. So we will align all these, and we can easily remove the wire from here. Yes, so this is now out. So this frees our one brake, and similarly we can remove the other side. Next step is we will take out the wheels. So we need to invert the cycle upside down. First we will remove the front tire from the front fork. We will need to use a ring spanner which is for 14 mm and 15 mm nuts. So 14 mm nut is there, which is used with the washers here. We have a nut here. We have a lock washer here, and then there's a lock washer which is fitted inside a small cavity. If you can see, this is a small cavity here. So this is fitted here, and then inside, if you can focus, we have another lock nut. Then there is a cone which you can see. I can just show with the cone wrench. So this cone wrench is fitted here. So this location is the cone, and beside cone towards the inside we have axle, on which touching cone as well as the axle we have balls, a set of balls which rolls. So this combination is available on both sides of the axle. So now we will remove the rear axle. So rear axle has got the similar assembly, but the design of the fork is a little different. So the front fork, if you can see, this is having a tilt which is towards back side. Okay, so this location of the jaws on the front fork, they are pointing backwards. So when the bicycle moves in the forward direction, the resistance which is there for the clamping of the nuts on axle, this keeps the axle in position. But in the rear side, if you see, the fork has got a position which is pointing towards the forward direction, right? So rear wheel has a tendency to slip backwards, front wheel has a tendency to slip towards the front side. So this design, and this element which is just here, this is a forged steel which is very nicely welded here to this pipe. So this material is different, this material part is different, this is different. So this is a complete bracket which is available, and similar on the other side. We have the nut, then washer, we have a lock nut in position, then there is a cone, and then there is a sprocket, and this sprocket has got a mechanism which lets it move in the forward direction, but it gets locked as you just see. I cannot move it backward. And chain also has got a unique link. There are several links you can see. So there is a unique link somewhere which we can show you in a while, which can be used to extend or remove the chain. So this is available here. You can see this is a unique part here. So on every chain you will find this is special lock. So the chain is not endless chain, but it is made circular for the required length using this part here. So this is the joint on the chain here. Now we will open out the crank assembly. We have the press fit extension on these pedals. So we will not remove this, but these are the points. These are the quarter pins which we need to remove to take out these cranks out. 11 mm D-spanner for this, and we will open this up. Quarter is a one-time use item. It is of mild steel, which is more ductile and little softer compared to the other materials which are used for crank and axle. So it slips into the position, takes its position, and if we try to take it out by hammering, it may bend and it may get deteriorated. So just to reuse for our activity, we can just make use of a wooden piece to slip the quarter on other side, and then the quarter is slipped out. So this quarter is a mild steel piece, and you can see this portion of this, it slides with this flat part on axle, and this has got a taper. You can see this is a tapered, and this tapered edge, as it is slipped down, it locks in. but because this is a softer material compared to the material of axle and the crank, so this deforms a little bit to take the shape. So generally we do not reuse the cotter, but because we haven't used the cycle too much, so this has not deformed much and it can be reused maybe for 1 or 2 cycles. Similarly, we will remove the cotter on other side. The crank, the front chain sprocket, and both sides cotter pins, they are removed. So you can see we have now axle which is located in this bottom of the cone or the frame of the cycle. So this is called bottom bracket. So this is the lock nut which has got 2 grooves here, and we will use this variable pin wrench, adjustable wrench, to open the lock nut first. And then we will use this spanner to take out bottom bracket cup. So this is the proper way of doing it. This is the axle with 2 bearings and a spacer in between. This is the axle component, the 2 bearings, and there is a spacer to keep these 2 bearings in place. So let's open the bottom bracket from other side, which is check nut. So you can see this. We will put here the bottom bracket wrench. Thread on this bottom bracket on this side is left-handed. The other part which we took from this side with the very adjustable wrench, it has got right-handed thread. You can see threads, and these threads are left-handed threads. On axle we always have a groove on each side, so because this is centered while manufacturing this, and we have a spacer, so there should be a small clearance created so that we can put the forks of the bearing puller. So bearing puller has got 3 forks, and they should be first opened and clamp the recess, and so that the internal pin on the bearing puller, it should touch the groove here on the axle. We will now use ratchet to tighten this. So as we will tighten this, the bearing which has got interference fit on the axle, it will slide from its seat. So you can see now, we can remove the bearing on other side. Here we can see axle, 2 bearings, and this is the spacer. So on this bearing, you can see here there's a bearing on this axle. You can see here this is a bearing seat. This is a small projection, and on the end of the projection you can see there's a small step which we use to locate the recess, the inner recess. So bearing has got 2 recesses. One is outer recess, one is the inner recess. So these are 2 steel parts, and in between there are recirculating balls which are held with a cage inside, and this inner recess is made to locate against this corner, this one, and we have this seat which has got a diameter which is little larger than the internal diameter of this bearing. So we have a press fit between these 2 components. So for larger components, larger axles, people first put the bearings in an induction furnace, or they just heat up the internal recess so that it expands with thermal expansion, and then it is made to take its position on the bearing seat. So just to locate that the two bearings are properly positioned, this is a spacer which is put inside. This is a nylon spacer. This spacer will touch the outer recesses. It will not allow any dust particles to get accumulated from this side. So once we will put these two bearings together, we'll show you how we can use the bearing puller to put these two to its final position. We can use the tools with 14 mm socket and extension rod to tighten the bearing to its seat. So bearing will slide to its position. So we will use the freewheel wrench to open the rear sprocket. So you can see the rear sprocket has got threads here. So at this location, and these threads, they are tightened. So we need to use these two small cavities where this freewheel wrench will be tightened. So this pin, this one here, will get clamped against one of these small cavities. So we will clamp this first in its position. And now we will turn this. This rear sprocket can be opened like this. So if some way like somebody has used this cycle quite a lot, if you need to change this rear sprocket, this is a procedure which can be used. So once this freewheel is out, this rear sprocket is out, and this rear sprocket has a property which it turns only in one direction. It has got ratchets, so it slides in one direction and it gets locked if you try to push it on other side. So while we pedal to power the rear cycle, so we move in this direction so that the axle moves along with it, and when we have a resting position, then this rear sprocket, it turns free over the ratchets. As we will remove the axle. So first component which we will take out is the main nut, washer, and then we have lock nut. So after lock nut we have spacer. So there are two spacers on this axle, which is real axle, and then we have a cone. So this cone wrench can be used to locate the cone. Now you can see the profile of the cone. This is having a cut to support the balls which are fitted inside. So this hub has got a location for the set of balls inside, and once we set the cone inside, so on one side the balls touch the inner side of this hub, and on other side these balls touch here. So the point contact is maintained between the cone at this location and the balls, and then we have the contact with this. So when we hold this axle tight at its position, so the cone is located with the lock nut at its position, tightened against the assembly. On the other side there are also ball and cone, and we have this hub which freely moves over the balls on touching this cone. So you can see the small mark where the black coating is removed because of the ball sliding over the cone. There are a set of balls on one side of the hub, there is a set of ball on other side, and this one cone on left and one cone towards right. They have location of hub in between, and they have balls which connect on this surface and on this surface, and over balls the hub freely rotates. And on one side of hub we have the sprocket which we showed you. We can take out the balls from the hub. We have now axle which is disassembled. So on this side you can see cone, spacer, lock nut, washer, the nut, and then on other side we have just removed from one side 9 balls are there on one side, and there are 9 balls which we have kept here for the other side. Then the cone, then the hub will be there, 9 balls here, then hub, then 9 balls which we will put with the grease, and then we will have cone, we will have then spacer, lock nut, washer and nut, and this rear sprocket we will fit using this freewheel wrench, and we will use cone nut to adjust the cone to its location so that the clamping force between the two cones, it is just sufficient that the tire doesn't vibrate, and at the same time it can freely revolve around the axle. So we have disassembled so far the axle as well as the rear sprocket. Now we will disassemble the front fork or the handle assembly. We have 3 components here. One is handlebar assembly. This handlebar assembly is located here. You can see this is a small bracket which is holding this handlebar assembly against this top fork or this extension bar. This handlebar assembly has got a 6 mm Allen bolt here, and underneath inside we have a splined wedge which slides against a conical tapered machined wedge. We have one lock nut which keeps the handlebar in position, and there are 2 recesses which are holding 2 caged bearings which allow the free movement of the fork with respect to the frame. And as a safety feature we have one reflector at the front, one reflector which is there at the back. So we will remove the Allen bolt. So now you can see there is a small wedge. This splined wedge moves on this tapered pipe. So as we tighten this slides, and the effective diameter of this wedge and the pipe together, it starts increasing. So it clamps inside the fork, this particular assembly. So this gets clamped, so the handlebar will not now move relative to the fork. We will remove the fork now. This is a lock nut. We use baby cup wrench. It has under it a spacer, and then we have a spacer, and then ring spacer once more, and then we have the bracket which holds your reflector, and under this we have one inverted cone. You can see this. We will remove this. This is threaded to its location. So this is also a cone assembly as we see around the axle. So you can assume this extension of the fork to be working like an axle for your handlebar assembly. So we can show you So there is a shape which is similar to the cone assembly formation here. So there is a caged bearing under this on this side. So we will take the bearing out. Now you can see the bearing. So on this bearing, so this is held in over the fork at this location like this, right? So we will remove this first, then the cage bearing. So this cage, metal cage, this holds the balls in such a way that one side they are touching the inside of the cone, and on other side the balls are touching this particular part, the inner recess. So this is a special caged bearing where there is a metallic cage which holds the number of balls in it. It becomes very handy compared to other cycle assembly. We can easily locate these balls, we can put the grease, and it can be easily assembled and disassembled. So we are removing the frame, and you can see there is another bearing, and below the bearing you can see another conical surface which is formed here, and this is the upper side, and in the rear bottom of your frame assembly you can see this also has got a profile which is inverted circular kind of profile. So this is the location of the fork, and fork has got a hole here to drain out any water which is there. If somehow some water traps gets into the arm of the fork, so we have another design feature which takes out the water from these holes here. And this fork has got two supported blocks for the V block, and this is a separate part welded here, this is separate part welded here, this part is separate part, and this is connected to this upper part, and this is hard forged steel. You can see this is a special formation serration here, and there are very fine screw threads which are formed here. Now on this frame we have another last thing which is left is seat assembly. So you can see there is a centric or cam system which is here, which clamps this mechanism, and it becomes very handy to tighten or untighten the seat fork. So this is the seat rod. You can use like a seat rod of any length as suitable for some particular rider. And then we can see on this side, this is cam. So you can clamp using this side, right? The bolt can be clamped to a requisite compression, and then we can compress this arm which tightens further the fork for the seat. Beyond this you can just see the frame only. Now we have rear tire, front tire, handlebar, the front fork, seat, the crank and the front sprocket, axle, main axle, and we can show these components here only. So there are several components lying here, and we have some components which are here, the two quarters, the nuts and washer for the quarter, the BB cup, the lock nut for the BB cup. These are the components for the fork, front fork, the two bearings for the front fork, caged bearings, the rear axle, a pair of 9 balls which is used with one side of the cone on the rear axle, the other cone, spacer, lock nut, the sprocket. So all these components, these are the main component. If you just try to list down the total number of components on a cycle, they are around 200-300 different components, So which, if you see the multiples of on every spoke here which is connecting to the hub, we have a special nut which locates this rim in a pre-tension position. So all these wires, they're in pre-tension. So the moment we load on the axle, so some of these spokes will get in compression, others one will go in tension. So the pre-tension which we give in the beginning for the rim to hold this in its position, it creates a kind of stress in the frame which prevents it from bending. So there are n number of components which you can see in different locations, different nuts, bolts and other components. So we will try to put this assembly back and we will see how well we can ride this bicycle after assembling ourselves. So the seat is being assembled first, so we will insert the seat post. This is the extension rod for the seat. So this is locked to its position. So you can see how fast it is to assemble this cycle. We will assemble the fork now. So on fork we should use small quantity of grease. So we will show you that how this is being applied. So you take small amount of grease so that there is always a lubrication on the parts. So we will put this component here. So fork is located now. We will apply grease a little bit. Now we'll put the upper cone and tighten this. So we should ensure that sufficient place should be there, while there should not be any lateral up and down motion of this fork. So we will tighten it to that position. So this is the washer for front reflector, then another washer on the top of front reflector, then we will have lock nut. Now this lock nut will hold the upper cone and the end of the fork in position. So there will not be any chance that the upper cone which is holding this bearing here will now slide back and forth. So everything will be held in position. So we will tighten this. Now we will insert the handlebar assembly. So we will see this cut on the wedge, the slant cut, and this cut on the pipe. This should match. So this should match like this, and initially they will have to be loose so that the diameter of these two are put in such a way that they can be slided down to the hole here inside the fork tube. So we will put this. So this is now sliding. So in this position at a required depth, so that it is now has gone in properly, we are tightening it with the Allen bolt. So as we tight, the wedge slides on the taper cut on the pipe and it grips the fork here inside. The handlebar and the front tubes, they should be aligned. So we will check that, and now we will tighten it further. So after ensuring the forks are in right position, now this assembly is done. Now we will put the BB cup assembly, the axle first. So this BB cup towards right side is put first, which has got left hand thread. This will be tightened to its position with BB cup wrench. So once we have ensured that it is tightened enough, we will use the axle. So axle, you can see it has got one side which is little longer than the other one. So the longer side will go towards the crank side and the shorter side will go towards the other side. So we will first put the BB cup here and bottom bracket cup. This will be tightened using the adjustable wrench, adjustable bottom bracket wrench. Now once we have tightened this, we will use the lock nut. So lock nut will also be tightened using the BB wrench. Okay. Now we will put the left crank. So left crank will be held in position such that the cut which is there on axle and offset which is here, this should match so that we can slide the quarter pin into this. So quarter pin will be slided into it. So it is to be hammered here. And now we will put the washer and lock this. So we're going to assemble the front tire. This is, we're going to assemble the rear tire assembly. So grease need to be applied first. Assemble the rear sprocket. This portion will remain towards the inside, and this will face outside, and we will use either of these two grooves, the small cavities, to hold the pin, right, of this freewheel wrench. So we will locate this first onto this sprocket. So sprocket is located here on the tire. Sprocket is now located on the axle, and we will locate this freewheel wrench, and now this will be tightened so that with respect to axle hub, this will not move. Right, so lock nut is positioned, and now we will put the spacer on other side. So the cone is already tightened. Spacer is located, and then lock nut is being positioned. So lock nut is tightened so that it will not slip. Now we will put the washer. So now we will tighten this wheel in such a way that the wheel will remain exactly in the middle of the two forks here, as well as the location of the bolts is such that the chain is in a tight position. So now we will clamp the brakes, move the cycle upside down. First we will put the rear brakes. So it is easy because we haven't touched the other parts of the brake. So we will just clamp this and take the wire to the rear handle. Now we will adjust the rear brake first. So first we will locate the wire into the handlebar. And now we will clamp the rear hinge. So if there is any adjustment which is required to locate the brake, so we will unscrew this, and this extension can be shortened or longer depending upon the braking required. And now we will do the front brakes. Fix the front brakes. We can fine tune these brakes from here, and similarly the rear one. Now the cycle is ready for testing. That's it.